one-step equations for something like this. That's a one-step. One step because if you look at the side with the x on it, there's only one other number there, 7. Or negative 7. That's the only number. Once we get rid of that, we have an answer for x. Now, on the side with the x, we have two numbers. 2 and minus 1 here. We got 7 and 3 here, and 3 and 7 here. So there's two numbers on the side, so we got to get rid of two things in order to find what x is. So it's even, it's less intuitive now, it's less obvious what the answer to some of these questions is. Just using the box and going, oh, trial and error might work out. Some of these answers are going to be fractions. Some of them might be negative numbers. So it's trickier to work out. That's why we need to make sure we have a formulaic method to do this. All right. So for this first one, I am going to do something similar we did with the one step. We are going to get rid of this subtraction of 1. How do I get rid of the subtraction of 1? Do the opposite, yes. Add 1 to both sides of this equal sign barrier. And then I draw a line underneath, and then I know that every time I do something like this, something's going to go. The minus 1 is gone, that's great. Minus 1 plus 1 is 0. 2x is still here. And the equal sign is still there, and 13 plus 1 is 14. And now we start again. We've done one step, now we're going to do a second step. How do I get rid of 2 times x? Yeah.
Divide by 2.
Do the opposite operation, divide by 2 here, divide by 2 here. 2 into 2 goes once, so I'm just left with a single x. 14 divided by 2 is 7. So now I have my answer. You can always test to see if your answer works. In my original statement, that is 2x minus 1 is equal to 13. That's 2 times some number minus 1 is equal to 13. My answer was 7 here. Does it work out? Yeah, because this would be 14 minus 1 to give 13. That's correct. So I can test. If you want, you don't have to. That's just a little test at any stage to make sure you're correct. Okay, let's do the second one. You always have a choice which one to get rid of first, to get rid of the 3 or the 7 here first. It is much easier to get rid of. If I can ever add and subtract first, I will do that. So I can subtract here and I'll get rid of this 3 rather than having to multiply by 7 first. Remember, if I multiply, I have to multiply the whole side, so I have to multiply the 3 and the 12. Okay, so I'm going to subtract 3 first from both sides of the equal sign, draw a line underneath. X divided by 7 is still x divided by 7. Plus 3 minus 3 is the thing that goes to nothing. And over here I'm left with 12, take away 3, which is 9. And now I want to find what my answer is by doing the opposite operation to get rid of dividing by 7. So I times both sides by 7. Most of the way I'm stacking my work underneath. I don't go over to the right here, I just go underneath. So it makes logical progression sense. I can read it a bit like a book. 7 and 7 cancel out. X is left behind. 9 times 7 is 63. I can do a little test. 63 divided by 7 is 9. 9 plus 3 is 12. Yeah, it works out. This next one, what am I going to do first on the third one?
Just minus 7.
So you have a choice here. You have 3 numbers, 5, 3, 7. I can either do something with 5, do something with 3, do something with 7. Now the x is on the right hand side here, so it's a bit unusual. But if I get a final answer 5 equals x, that's okay. That's just, I can read x is still 5. So it doesn't matter which side the x is on, as long as you work down, you get 1x. So I'm going to work with the right hand side this time, a little bit unusual. And I'm going to do my first step of adding 7 to both sides. Because I always have to get rid of the numbers with the x. That side is the numbers I'm trying to look at. So 5 plus 7 here is 12, equal sign still here, 3x still here, 7 things. 7, that's gone. That's exactly what I wanted. I'm down to only one number with the x, the 3. Final thing, divide by 3 both sides, yes. Some people, instead of divide by 3 like this, like to divide by 3 like this. Probably more mathematicians won't use the divide by sign, they'll use just the line. Division fraction is division. 3 into 3 goes once, and 3 into 12 goes 4 times. And is it okay if the x is on the right hand side? Yeah, that's fine. I can just leave it like that. If you like, you can swap the sides. X equals 4 is the same as 4 equals x. Just going to do one more example. What happens if I have something like this? Tyler. Why wouldn't I add 3 to both sides?
Because it's still
Yeah, so for this one you can notice that the 4 divides both the x and the 3. You see that? It's different than this one where the 7 just divided the x. So if I want to add 3 to both sides, that wouldn't make sense because this is actually 3/4. So the first step I've got to do here is actually multiply. So this is a bit unusual. If I'm dividing everything, I multiply first, both sides. So if I multiply this side by 4, and this side by 4, what happens is, well, this whole fraction is divided by 4, so if I multiply it by 4, the whole thing will cancel out. That 4 will cancel out for both the x and the 3. And I'm just left with x minus 3. 2 times 4 is 8. And now it becomes a simpler one-step equation. I actually just add to finish. And x is all in. So there are 4 examples. Now it's your turn.